Good afternoon and welcome to my presentation. I will show you a proposal for organizing source code variability in the Git version control system. This work is presented by Leonardo and Junior, and I will show you the main topics inside the article. So let's begin with the schedule. First, I'm going to show you the motivation. I will show you the context of the problem. Next, I will show you a little of the background. I will explain the internal part of the Git version control and the de facto method of the server engineering to create server lines. Next, I will show you the proposal. Here, I will present a new graph called the feature branch graph that was created for the proposal. And finally, I'm going to show you the ongoing work and the discussion. So let's begin with the motivation. Software companies evolve over time. The source code of a product also evolves over time. That means that the source code of a product in 1 year is different from the source code of the same product in the next year. Sometimes some of these companies, to cover different market segments, use a practice called clone unknown. So given a version of a product, most of the time the last version, they create different variants to cover the market segments. However, this approach generates an issue that is now you have to work multiple times in the same common part of these products. So that is a problem. If you use the clone unknown practice over time, you will generate different products. However, most of these products will have repetitive code between the products. And that is a problem for the maintenance. We know that server line solves this issue, but the solution also generates different questions and problems. That is, how to organize the evolution of a server line and how to organize the evolution of the source code of a server line. When we talk about the source code of a server line, we will talk about all the resources to generate each of the artifacts of each of the products that belongs to the server line. That means that a product have also different artifacts that is not only the source code of the server product. They could have a model, figures, documentation, and so on. So let's return to the problem. How to manage the evolution of the server line? What happens when you add new features to the server line? A possible solution is treat the source code of the server line like a single product in a version control. However, this pollutes the source code of the server line. For example, here in the figure, I show you some lines of code that are polluted with the antenna directive of the condition compilation mechanisms to manage the variability in the server line. So we know that there's different mechanisms to manage the variability in a server line. You can use the feature-oriented programming, delta-oriented programming, and so on. When you have a pollute code, you can generate different hard tags. For example, when you are adding new code to a feature, you can affect different features that can generate different problems. So that is a hard problem. So in this part, I will show you the background that you require to understand the proposal. So the solar power line engineering show notion of how to develop a solar power line. The de facto method divide the process in two, the application engineering and domain engineering. We know that domain engineering, you define the variability model for the solar power line, and you implement the domain implementation artifact that you will use to generate the product in the application engineering process. In the application engineering process, we select the feature that we want in a particular product, and then we use the domain implementation artifact to generate the product that we wanted. We need to highlight here the feature model, that is a variability model, because it is used to generate the feature branching graph that is proposed in this work, along with the proposal. So, on the other hand, we have the Git version control, that is a tool to manage different versions of a product software. So the Git version controller have 4 kinds of objects that are the tag, commit, tree, and blob objects. The head branch reference are only reference. So we know that developers know how to create a commit, merge branches. That is in the part 1 of that Git object model. But most of them don't know that there exists the tree and blob objects that are that objects that store the information. For example, here we have a working directory. Git will generate the objects of that working directory. And as we can see, the blob and tree objects store the information of the working directory. So when we manipulate commits, we only manipulate reference to that tree and blob objects, or reference to a specific commit. So in this section, I will present the proposal. So what we want that developers focus more on features instead of the products of the software line. We want that they maintain the source code of a feature in a feature branch called feature branch. We want that they maintain the directives to manage the variability of the software line in branches called variability branches. To do that, we will need an artifact called the feature branch graph that it's presented in this work. To create a feature branching graph, you will need to use the feature model. And you can see the feature branching graph, a branching model for store the source code of the software line in the Git version control system. In our proposal, we also need to talk the down and product conflicts that we define as the conflict when you spread the commit. Well, the down conflict is defined when you spread the commit to the children nodes in the feature branch graph. And the product conflict is when you try to merge the different feature branches or different nodes in the feature branching graph to generate a product. So how to generate? So to create a feature branching graph, you will need to see the feature model in a different perspective. You will need to see the feature model as after feature and concrete feature and leaf feature. So after feature are features that are only to organize the feature model, the features in the feature model. And concrete features can be selected in the configuration of the product in the feature model. And these features are features that are in the leaf part of the feature model. So After that, you will need to follow 3 rules. The first rule is for an after feature that is not a feature leaf, you will need to create a variability branch. For concrete feature that is a feature leaf, you will need to create a feature branch. For concrete feature that is not a feature leaf, you will need to create 2 branches, one for the variability, one for the feature. So here we have an example, and we create a feature branch graph of the feature model of the elevator solar product line. So another important part of the approach is that we need to spread the commits. So when we add a commit in a branch in our feature branch graph, we need to spread that commit to his children. So in this case, we are adding a new commit to the modes branch. So we need to spread that commit to the modes variability. And after that, that commit would be spread to the Sabbath, FIFO, or path because are children of the modes variability. So if we have a conflict, we call that conflict down conflict. And we need to resolve it adding another commit with condition compilation directives or with the variability realization mechanism that you're using to resolve the conflict in the variability branch. In that case, in the modes variability. And after that, if you add a comment, you need to spread that comment. So as you can see, when we spread the comments, we also are polluting the feature branching graph. So that is an issue that we resolved in a different version of that proposal. However, it's under experimentation, so will be present maybe in the next year or in the few next years. So how you integrate that proposal when you develop a solar product line? So after you collect the existing artifact and find the common parts and particular parts and create a feature model and the configuration of each of these products and the feature branch graph, you will need to add the common parts on the branches that have low depth. And you need to add the particular parts in branches that have more depth. So when you resolve the down conflict, when you spread that commit and you resolve the product conflict, you will add in the variability of the solar product line in that variability branches, like is in step 8. So how to generate a product? For example, if we have the elevator solar product line, we select some feature of this solar product line. The process is that you will need to generate a temporary branch from the root of the feature branching graph. Next, you will need to merge that temporary branch with the nodes that are related to the selected features. And that can generate that we call product conflicts. So you will need to resolve that product conflict before to generate a product. So when you have the merge, you will need to create a product branch. And in that product branch, from the temporary branch, you will need to resolve the variability of the product branch that have in the product branch. When we are talking about resolve the variability, we said we are talking about when you use the tool, for example, in the condition compilation to remove the directives of the condition compilation and generate the product. So what are the ongoing work and some of the discussion here? Can the proposal work for solar product line with 20 or more features? The answer is we don't know. We recommend don't use it until we present more technical experimentations. If the proposal can be integrated with the Git flow of Bis and Reason, The answer is yes, you can integrate with the Git flow if you treat that features as the masters in the Git flow. What are the disadvantages of using the approach proposed? Well, as you can see, and we said before, in the worst case, the source codes of each feature and pollute. That was the problem that we try to avoid. But that is in the worst case, né? Okay. So there is related work. Yes, you can use the ground approach model that focuses more on products instead of features. You can use also variability control systems like econs per mode. We described a little of this in our article, and you can check his articles. So that is the end of this presentation, and thank you for attending this presentation. You can ask me if you have some questions in my email. Good night.